everyone, I am Vedant and I am going to discuss about plotting graph for normal distribution in this video. So in earlier video I have discussed about real life application of normal distribution. I have provided examples of technical marketing, finance, IQ graph plotting and economic management and everything. So you can refer that video once again if you want. In normal distribution, I want you guys to remember that when we graphically represent it, we obtain a bell-shaped curve. That curve I will show you. This is the curve that we obtained. I want you guys to remember this for our further reference. On y-axis, it is considered as probability density, and on x-axis, we are considering it mean. So this is the graph actually we are going to obtain later in further part of this video. Just remember this. And coming on with the formula, let's revise it once and we can move further. So this is the normal distribution formula. Go through it once. And the what are the terms meaning here are demonstrated here. X, it is the value of variable or data that is being examined, and f of x, it is the probability function. Mu stands for the mean, and sigma stands for standard deviation. These are the two factors that we will alter and we will see what changes it makes in the graph. So the next part of video I will divide it into two sessions. The first part will deal with what are changes of mu and sigma that we will do, and what are the changes it occurs in the graph, and in further part we'll set the ranges and we'll see what are their application. So we are done with the revising formula and just quickly jump into the code. This is the online platform where we are going to run our code. I think you guys are already familiar with this website. So let's bring the code. Starting with basic one. So we have plotted the curve from 0 to 100 on x-axis, and this d norm is the normal distribution keyword. We are providing mean value as 49 and standard deviation value as 10. So let's see what happens when we plot this one. On x-axis we'll take it f of x. So curve is ready. You guys can see on a y-axis we are taking f of x, and x value is from 0 to 100 as we are providing it, and mean value is 49. So we can see the peak hitting it as 59. So what happens when we change these values? Let's take some lower values such as 25 will take. When we run this code, we'll obtain the curve related to these values. Once we are done with one, we'll see it. See, you guys can see now the peak has shifted from 49 to 25. So what are its application, real life application? Let us assume that this is 0 to 100 is the lifespan of human, and this is the population density ratios. At 25 we are taking. So at what age most of people stop their learning and start their going to their career? Let's say take it at 25. Based on that, calculation can be made about what right age, what is the right age for stopping your education and moving on with your career. So what is the minimum education that you should have? This kind of calculation can be done using these normal distributions. So let's generalizing this example. We'll take our own example. Let's have this as a mean as 7.5, and we'll decrease standard deviation to 1, and this 0 to 100 will decrease it as 10. So when the graph is being plotted, we'll obtain this kind of curve. You guys can see the on x-axis we are taking 0 to 10, and this is the density ratios, and 7.5 we are having the mean value. So these are the changes that we can see when we alter the values of standard deviation and mean on a graph. So next part of this I will show ranging of curves and what happens when we use ranges. First example I will show what happens when we shade a part that is greater than 0. I will change this color to red for better vision. So I will run this code, and you guys will see that a graph has been plotted, and it is shaded even. So this is the normal curve based on our given data, and greater than 0 part are being shaded as we are giving the value as greater than 0. So we can also alter this value, and based on that we can also alter this coverage that will be shown in the next example. So bringing on with the next example, where 95% of the graph we are going to coverage. So I am naming it as 95% coverage, and when I try and run this code, I will get a graph beside the earlier one graph. Now you guys can see. For better visual, I will change this color to blue. When I change it to blue and run it once again, I will get again this code. So while this graph is being plotted, I want you guys to check out that these are the ratios based on that where I am going to plot this. See, you guys can see 95% of the curve is being covered. So I said I will demonstrate how it is actually being done. I discussed about marketing trading in my previous videos. So let us assume that this is a normal curve is of a logarithm of forex ratios, and this curve we have obtained. and we want to highlight this part, and at this peak we'll see at what cutoff points it is going to show. So when I alter this value, that is it is 1 point minus 1.96, I will change it to 0.96, and here on plus 1.96 I will alter it to 0.96. Then the curve reduces and very less part of curve is being highlighted. So when you obtain the result, you guys can see. So based on the calculation made, we can have a horizontal points that we can be calculated, and we can decide that at what the curve will fall, at what the curve is going to rise. Based on that calculation, it will help the analyst to make the decision about stocks and all. When we alter, no, it's not like that. We should take both the values same. Like I will decrease this positive scale value. Like I will 0.23. So we'll take it. The values of when we alter it, the curve also changes. You guys can see over here. The curve also changes with behavior of this. So this is what happens in real life application. Not only just this, for examples like what's the right shoe for a human, means what are the majority of people shoe length, what's the average height, what's the average birth weight of a baby, newborn babies. This all calculation are made only on this type of system. So let's consider this. This graph involves negative as well as positive part. This type of graphs are rarely used. More than this, we are going to use graphs which ranges from 0 to 4, 0 to 10, or 0 to any limit. That kind of graphs are used more than this type. So I think you guys are clear with how this works, and how the normal distribution takes place, and its what are advantages of altering its ranges, how the calculations are made. I think you guys are understood it. Thank you for watching this video.